name is Muhammad Akmal bin Muhammad Akil. I will explain the relationship between induced EMF and flux. In this experiment, we take a magnet and a coil, and then we connect it to a galvanometer across the coil. Initially, the magnet is at rest, so there is no deflection in the galvanometer, which means the needle of the galvanometer is either at zero or at the center. We will conduct an experiment, a very simple experiment that will involve only magnetic bar, solenoid and multimeter. Firstly, as you can see, when the magnetic bar is on top of the solenoid, there is no movement of the multimeter. However, when the magnetic bar passes through the solenoid, as you can see, there is a slight deflection on the multimeter as we move the magnetic bar around the solenoid. This shows that there is magnetic induction that occurs inside the solenoid.
My name is Mahendran. Today I will be explaining the relationship between EMF and the flux. Okay. When the magnet is moved towards the coil, the needle of the galvanometer deflects in one direction. When the magnet is held stationary at the position, the needle of the galvanometer returns back to its zero position. Now, when the magnet is moved away from the coil, there is some deflection in the needle, but in opposite direction, and again when the magnet becomes stationary at that point with respect to coil, the needle of the galvanometer returns back to the zero position.
My name is Alex. Today I'll be explaining Faraday's first law. Faraday's first law states that any change in the magnetic field of a coil of wire will cause an EMF to be induced in the coil. So basically it means that changes in the magnetic field will cause an induced current in the coil itself. This EMF induced is called the induced EMF, and if the conductor circuit is closed, the current will also circulate through the circuit, and this current is called induced current. So that is why the galvanometer needle deflects whenever we move the magnet in and out from the coil. Thank you.
I will explain on Faraday's second law. Faraday's second law states that the magnitude of EMF induced in the coil is equal to the rate of change of flux that linkage the coil. The flux linkage of the coil is the product of number of turns in the coil, and flux is associated with the coil.
My name is Muhammad bin Sapri. So from this, from our project, this electromagnetic course. So the conclusion is, from this experiment, Faraday and we concluded that whenever there is a relative motion between conductor and a magnetic field, the flux linkage with a coil changes, and this change in flux induces a voltage across the coil. So that's all from us. Thank you.